All right. So in this section, this is introduction to factoring. The first part of this is they want us to factor the expression. Basically, we need to find the greatest common factor and then factor that out. And then the second part of this is they want us to factor. Okay, so if we look at the first one here, okay, so let's look at the coefficients, which are 5, 15, and -15 and -10. What will be the greatest common factor between those three numbers? 5. Very good, right? So 5 is the greatest common factor between them, right? So I can pull out a 5. Now let's look at the x's. Which is the greatest common factor between the x terms? X squared, right? So basically, a lot of times is you look for the lowest power exponent. Okay, and that would most likely be the greatest common factor between them. Okay, and the reason being is because, if you have x equals, x to the third, you don't have enough for x squared, and also for x to the fourth, you wouldn't have enough for x squared. So one of the trick is to look for the lowest exponent, and then that would be your, in regards to the variable term, the greatest common factor. Okay, so so I'm going to take out an x squared here. Right? And then I'm going to be left with what? Well, what can I multiply to x squared will give me x to the fourth? What can I multiply to x squared to give me x to the fourth? X squared, yes. Okay. So I have x squared here. And then what can I multiply to x squared to give me x to the cube? Good. X. And then I can't forget because I need to multiply something to give me 15, right? So that should just be 3, right? 5 times 3 will give me 15. So I have 3x. And then to get to 10, I have to multiply that by 2. So that's minus 2. How about this one? I got x squared and x squared. Do I need to do anything? No, right? I can multiply by 1, but again, I get the same answer. Same thing for this one. I can put a 1 there, but I still get the same answer. Okay? So since there's a number there, then I'll leave it as minus 2. But if there wasn't something there, then I would put that 1 as a placeholder. Okay? So when I multiply, I get the same result back. So 5x squared times x squared is going to give us 5x to the fourth. 5x squared times -3x is going to give us -15x to the third. And 5x squared minus 2 is going to, times minus 2 is going to give us -10x squared. Okay? So if they ask for the greatest common factor, then this would be our greatest common factor. If they just said factored it or factored the expression, then this is what we have. Okay? So why don't you try the next one there? Again, I need to look at this, part by part. So I look at the threes first, right? So the greatest common factor between them is going to be 3, because 3 can go into 3 and 3 can go into 6. Okay? All right. So 3 is for the coefficient, it'll be 3. Now I look at the r's, all right? We go to the lowest power. R cube is the lowest power, so that's the biggest number, the biggest R value we can pull out. Okay, so that would be R cube. And then for t squared, for t, again, we look at this one because it has to be the smallest exponents, so we can pull out a t-square. Okay, so again, if it asked us if what's the greatest common factor, then it would be this term. Okay, if they just want the factor expression, so we pull that out, and then we just put in what was left. So if we took out 3r cubed t squared, then we have a t left over because it's t cubed, so 2 plus 1 will give us that 3 there. Okay, to get to 6, we can do a 2, right? 3 times 2 is 6. The r4, we have r left over. All right, because we already used up 3, we need one more. And for the t cubed, well, we don't have to worry about that one. Okay, I'm sorry, for t squared. It's the same, so we just leave it alone. Okay, so this is what it would be if we factor the expression 3r to the third t squared times t to the first power minus 2r. Now, again, you don't have to write the 1 there. I'm just emphasizing that hold on here. Yeah, emphasizing that this was a t squared, and so this is t1. So that gave us t to the third. Okay. So this would be our answer if we were to factor the expression. All right, so notice that on both of these terms we have y minus 2. So if I factor that out, I pull out of y minus 2. And so I'm left with the 3y squared on the left, and then the plus 5 on the right. Okay, and so this would be my answer if I pulled out. Now I can also write it as, like this. There's basically saying the same thing. Okay. Okay, so this next part is asking us to do what's called factor by grouping. So how do we do that? Well, notice that there are 4 terms here, so it's going to work with 4 terms most of the time. Okay, so what I need to do is I need to break up these 4 terms. Okay, so I'm going to write x cubed plus 6x squared plus x plus 6. Okay, so that's the very first thing I need to do. There shouldn't be an equal sign here. Just factoring. Okay. So now let's look on the left side here. What is the greatest common factor I can pull out of x cubed and 6x squared? Okay. So once you separate them into groups of 2, all right, you can do the first 2 on the left and then the first 2, the next 2 to the right of that. Okay. So what you do next is you want to factor out this terms here. Okay, and hopefully this term here, or this binomial, will look the same as the second binomial. Okay, so in this case I have x squared, and when I pull that out, I have x left over because I had a 3. 3 plus 2, I'm sorry, 3 minus 2 will give me 1, or 1 plus 2 will give me 3. Okay, and then I have plus, again, I don't have to put that 1 there because that's automatically assumed. Okay, then I'll have the 6, right? So, because I pulled that out. And this is my goal. So notice that the second part of this is x plus 6. And my goal when I'm doing factor by grouping is to also get that second binomial to be the same. Okay? And which we did here. This binomial is the same as this binomial here. Okay? So we'll have plus x plus 6. Okay. So now I can do what I just did on the last one. Okay. Where I noticed that oops, we had y minus 2. Right? So we factor that out. So notice that we both have x plus 6, so we're going to take that out. So we have x plus 6, okay? And then left with x squared plus 1, right? Because when I multiply it back, I should get the same. So x plus 6 times x squared is this. X plus 6 times 1 is also this. So we can't just leave it blank. That's going to be assumed that it's 0, but it's not. Okay? There's actually a 1 there as a placeholder. All right, so again, the first thing you want to do is you want to separate them. So I want to have 2z cubed minus 6z squared plus 5z minus 15. All right, so here, the greatest common factor between 2 and 6 is going to be 2. The greatest common factor between z cubed and z squared will be the lowest term in this variable, which is z squared. So that means we have a z left over for here, and then the minus 3 on the right side here. Okay, because if I were to multiply that, 2z squared times z is 2z cubed. 2z squared times negative 3 is negative 6z squared. Okay? Right? And the same thing for this one. I know that 5 is a common factor between them, so we're going to pull out a 5. All right, and we'll have z there as a placeholder. Okay, can't just leave it blank. And then minus 3. Okay, so now I have the same factor. I can pull that out. So I'm left with 2z squared plus 5. So I know this might throw people off, but the square brackets and the regular parentheses, okay? I'm just trying to distinguish between the two. All right. All right, any questions? Okay, let's try another one here. Okay, so let's say we have 18y to the 5th plus 27y to the 4th plus 12y to the 3rd plus 18y squared. Okay. Okay, let's go over this one. All right. So first let's talk about the coefficients, the numbers in front of the variables. What's going to be my greatest common factor between all four terms? What would that be? What's the greatest common factor of the four terms of the coefficients? 3. Good. All right, so I can take out a 3. So let's take out a 3. Okay. Now, all right, what about so anyway, when I take out a 3, let's just kind of go step by step here. I have a 6, I have a 9, okay, I have a 4, and I have another 6, right? Because 3 times 6 is 18, 3 times 9 is 27, 3 times 4 is 12, and then 3 times 6 again is 18. Okay? So that's what I have. Now, what about the variable? What's the greatest common factor with all the four terms? What's the highest I can pull out for the y's? Y squared, good. All right, I could take out a y square. So when I take out a y squared, then I have 3 left over on this one. I have 2 left over in this one. I have 1 left over in this one, and I don't have any left over. Okay, and then I'm just going to add those guys. Okay, all right. And now we can do some factor by grouping here. So I still got 3y squared in the front there. I'll leave that alone. But I can group this guys together and then group these guys together. So we have 6y cubed plus 9y squared plus 4y plus 6. Okay. Now I go here again. If I look at 6 and 9, right? What's going to be the greatest common factor between 6 and 9? 3, good. All right. And then what about between y cubed and y squared? What's the greatest common factor between these two guys? Good. Squared. Yes. Remember, it's always the lowest term, the lowest one with the lowest variable. Okay. All right. So in this case, oops. So we have y squared. Okay. So that means then I'll have 2y left over plus 3. Okay. We can double check. 3 times 2 is 6. Y squared times y is y to the third. 3 times 3 is going to give us 6. Okay? And then, of course, we have the y squared. So we're good. Okay? How about this one on this side? What can we take out there? What's the greatest common factor between 4y and 6? A 2. Good. Okay? So, going to take out a 2. So that gives us 2y plus 3, right? Because if I multiply, I get 2 times 2y is 4y, 2 times 3 is 6. Okay? So now what do you notice? Hey, we got the same factor again twice. So I can pull that sucker out, and then I can write down what am I left over. I'm left over with the 3y squared, and then I have the plus 2 on the right side. So basically what we can do is just, when we pull out the 2y plus cube, 2y plus 3, then we can just have 3y squared plus 2 being left over. So from here, it's the 3y squared, and then the plus 2 is coming from there. Okay. Now, don't forget the one that we had done originally. Okay. Which is this term in the front. Okay. So we need to bring that down. So that gives us 3. So 3.